So in previous week, we have looked at some example in Fourier transform properties. So for this week also, we will see few example on using frequency Fourier transform properties. Okay, so this is our first question. Okay, so verify time shifting property. Okay, so I think you have already know the time shifting property. Okay, so if I state it here, so if we have a signal in time domain, okay, we can convert it to Fourier, convert it to frequency domain using Fourier transform pair. So it will like this. Okay, so Fourier transform of xt is capital X omega, and inverse Fourier transform of x omega is simple xt. So this is the Fourier transform pair. Okay, so time shifting property is stated that if we have shifted this signal time, okay, so this is a time manipulating method, no? Manipulating method. So if we shifted the time, we will get the Fourier transform pair as e minus j omega naught t x omega. Okay, so this is the time shifting property. So if you know the Fourier transform of any signal xt, if you are given a time shifted signal, okay, the same signal time shifting, but shifted in time, you can find the Fourier transform using this identity without going through that principal approach, no, using transform pair, Fourier transform pair. Okay, you can directly evaluate it. Okay, so let's see how we can prove this. Okay, so we know this. Okay, so this is given. Fourier transform xt is x omega, so that is given. So we have to evaluate the Fourier transform of x t naught. We have to evaluate this Fourier transform of x t minus x t minus t naught. Okay, so if you use the Fourier transform pair, you know we can find the Fourier transform of this signal using that Fourier transform pair. Okay, minus infinity plus infinity, the given signal. Now the signal is xt t naught. Okay, is here minus j omega t dt. Okay, so this t is a variable and this omega also a variable, but in this form is omega t naught. Okay, this should be omega t naught. Okay, so this is the frequency shifting property. Okay, so this omega also a variable, that is the frequency, but when we are integrating with respect to t, we consider this omega as a constant. Okay, so we can proceed. So I will get a substitution. This t minus t naught, I will get it as tau. Okay, t minus t naught. So tau is equal to t minus t naught. Okay, this is a substitution. Okay. Okay, then now I am going to convert this terms into tau terms. Okay, that is, I am going to remove the t terms here. Okay, so first I have to remove this dt parts. Okay, so I differentiate this tau equal to t minus t naught with respect to t. So I will get d tau dt is equal to, here I will get the answer 1, and this is a constant, t naught is a constant. So if I do the differentiation, I will get 0. Okay, so d tau by dt is equal to 1. Okay, so d tau is equal to dt. So now I am going to substitute this value to this identity. Okay, that is Fourier transform of x t minus t naught. Okay, okay, so I will get minus infinity to plus infinity. Okay, so here t minus t naught, we got it as tau, so I will substitute it here. So here x, now it is x tau. Okay, t minus t naught is equal to tau, so I write down it as x tau, and here this tau, here this t. Okay, so t is equal to, so now I'm going to remove the t terms from this identity. Okay, so for this t, I'm going to substitute t is equal to t plus tau plus t naught. Ne? So from this we can get t is equal to tau plus t naught. So I'm going to substitute these terms here. So I will get e to the power minus j omega tau plus t naught. Now I remove these terms from this term. Okay, so I will get d tau. Okay, so what is the independent variable of this expression? What is the independent variable of this expression? Can someone tell? What is the independent variable of this expression, this identity? So I think you know the answer. Independent variable in this identity is tau. No, this is the independent variable tau. Okay, so this omega also variable, but we take this in respect to tau. So now we can consider this omega as a constant. Okay, and we have this t naught. It is definitely a constant. No, so now for this equation, for this identity, for this expression, the independent variable is tau. Okay, so I can simplify this term further. Okay, to get out some constant term. Okay, so I can get here e to the power minus j omega tau. Okay, so I can write it as like this, no? E minus j omega tau and e to the power minus j omega t naught. So I can write these terms like this, no? Okay, so this is tau. Okay, so and here we have the d tau. Okay, so what about this part? Is this a variable or is this a constant? Can anyone tell? Is this a constant or variable? This is a constant or variable. So this is a constant, no? This term is a constant because now we look at this expression with respect to tau. Okay, so tau is the independent variable. Okay, this tau is the independent variable. Although this omega is a variable, we can consider as a constant at this time. Okay, so if we look at this term, with respect to tau, this is a constant. Okay, so this is a constant. Okay, so we can get out that constant, this part. Okay, so I get out that constant because like this. Okay, so I have minus infinity to plus infinity x tau e minus j omega tau d tau. So what is this part? What is this part? Okay, so what is this part? So see that, okay, we have a xt signal. No, we have xt signal. It may be any kind of signal. Okay, sine wave, cosine wave, exponential function. We don't know what is the signal, but it is time domain signal. No? So here it is independent variable is time. Okay. So if we graph the xt with respect to time, it will get some shape. Okay, get a shape. We don't know the shape. Okay, because we don't know the signal. Okay, it is unknown signal. Okay, but if we remove these t terms and we write tau with respect to t, is there any difference between any different happen to this shape? Okay. So we are now get tau instead of t. Okay, for example, if xt, okay, if t is equal to say 2t plus 1. Okay, so if xt is equal to 2t plus 1, so if I draw this signal, okay, draw this signal, xt is equal to 2 plus 1. I get it as example. Okay, 2 plus 1. Okay, so if I draw this signal with respect to t, okay, so if t is 0, this value will be 1. Okay, this value will be 1. And if this value will be 1, okay, if t is 1, say 1, this value will be 3. Okay, so if it is 1, this value will be 3. Okay, and if it is 2, this value will be 5. So it will look like this, no? Okay, so if t is equal, if xt is equal to 0, then here it is minus half, no? Okay, so this signal look like this. Okay, so if I remove these t terms, and so I have xt, so this is the independent variable 2t plus 1. So I remove this t and I write it with respect to tau. So now x tau is equal to t tau plus 1. Okay, so if I draw this signal with respect to tau, okay, d tau plus 1, so it will look like this, no? Here it is minus half, here it is 0, and at 1 it will be 3, at 2 it will be 5. Okay, so this function and this function will be same, no? This signal and this signal is same, only change the letter. Okay, so this t is change it here to tau. It is only a letter is changing, but there is no effect, no? So in same wise, you can say that this x tau is same as xt, no any difference. So here e to the power j omega t, and if it is dt, so this integration we can tell as capital X omega Fourier transform of xt. Okay, but if this t tau is there, there is no difference, no? This tau is just a letter. Okay, independent variable. Now here independent variable is denoted by t. Here independent variable is denoted by tau. No any difference. Okay, so this part also, this one also we can consider as x omega. No, okay. So I hope you can understand. If you couldn't understand, please let me know. Okay, then I can explain it again. Okay, so we will get e j omega t naught capital X omega. Okay, so this is the Fourier transform of x t minus t naught. Okay, so so we have verified the time shifting property. That is, if xt has a Fourier transform of x omega, Fourier transform pair of x omega, then x t minus t naught will have the Fourier transform of e j omega t naught capital X omega. Okay, so this is the time shifting property. Okay, so we will see one example again.